First of all, this is week 12, right? 11.
Yes.
12. Nick?
I think it's 12.
Now that I second guessed myself, and you were right, it is 12. So our topics this week. I'm sorry to say we are all done with all those various networking theorem problems and stuff. We're done with that. The lab this week is maximum power transfer, which is directly connected to those. Read through the lab and look. It's got a lot. You build a circuit, you collect a whole bunch of data. But the topic this week we want to talk about are batteries and conductors. Next week, we're supposed to have exam 2, which I think we should go ahead and do that probably. We want to do it on Tuesday or Thursday?
Thursday. I always vote for Thursday.
Thursday. All right, Thursday we have exam 2. Equation sheet as always. Calculator for sure, as always. Pen, pencil, writing utensil, maybe multiples, preferably pencils, but I'm not going to get after you. Brain, all your knowledge, everything. It's going to cover everything since exam 1. So exam 1 was mostly like more advanced resistor circuits. Really, exam 2 is more advanced resistor circuits. It's going to be almost strictly, maybe some problems off today, but almost strictly off of all those networking theory problems. So make sure you can do mesh currents, nodal analysis, Thevenin equivalence, Norton equivalence. You should be able to do the Kirchhoff's current law and voltage law problems, though I'm probably not going to tell you specifically to do them. In fact, I might on the test just give you circuits and say solve them and let you pick the method, or I might tell you to solve it a certain way. So if you pick the method, then several of these we did. We did the problem on separate sets and let you do it like mesh currents and then nodal analysis. So it's maybe I'll let you do that and go, hey, can you show me what you would pick? They should both give you the same answer in the end. Just one's easier than the other. Okay, batteries. I'm going to tell you everything I'm going to tell you. Well, it's got through all the rest, but there's not a lot to work on batteries. So batteries are almost strictly. I'll cover some stuff, and then we'll talk about some of the knowledge you get the reading pretty heavy for most of it. But a reminder also, our text is about 20 years old in batteries. There's been a lot of batteries are a hot area. Modern lithium batteries existed then, but they're like the big thing now that we're using for everything. So feel free to go look those up. First of all, a battery cell. So batteries are made up of various cells inside. My schematic for them is that. A battery cell is 1.5 volts. And it's just a little cell that has chemical in it that strips electrons from strips charge from one conductor and moves them to the other naturally. You can do this. I know nobody gets to do this anymore. When I was a kid in middle school, we got to just have like a big fishbowl of acid out there. You put 2 electrodes in it, you can measure it. But you can do it if you do it like a potato battery. It does that because it's just acid inside, strips from one and moves to the other to get a voltage difference between them. So anything that's a chemical reaction that can do that. When I draw this, that's showing the multiple cells of the battery. So this is a place where the schematics are technically different, though we pretty much use them interchangeably because, well, I find a lot of schematics just plop this down and then write 9 volts next to it, which is fine. But technically, it's just a cell. Technically, this is any bat. And really, for some people, technically, you would add up the number of these to form the number of cells, but we almost never do. That's just a battery, and you put the voltage next to it. But I think we've had at least 1 or 2 assignments that do.
Yeah, the lab in the other class does something like that.
Yeah, and it's okay. There's nothing wrong with it. I'd say it's probably non-standard. But you'd probably do it. You'd probably see it in a textbook or something to set it up and go, oh, that's 12 volts. By the way, I'm going to do 64 volts now, so I'm going to draw this big thing for you to see it. Okay, now battery is just made from multiple cells. If we look at our, say, AA versus C versus D battery, they may be multiple cells in parallel, so they can all provide more current. It might be a bigger cell. If we have something like a 9 volt or 12 volt battery, that means I'm going to have multiple cells in series too, so it provides that higher potential. All right, so basics of batteries for us, unless you're working in the field, but you could be. I mean, we got Panasonic coming in over at DeSoto who's going to hire 5,000 people. I don't know how many electronics techs they're going to need out of that, but they're going to need some.
They make cameras, Panasonic?
I think they do make cameras, but I think what they're doing down there is just all battery production. And I don't know for sure what kind of batteries they are. My brain had assumed they're aimed at cars, big batteries for cars, but I don't know that I've ever heard that confirmed. So that might have been just my assumption. Okay. I'm trying to remember what else I wanted to hit on batteries. There's not a lot for me to hit on batteries, but there's a few things. Primary batteries are batteries that create this completely inside, use their chemical reaction, maintain their voltage until they run out. At some point they start to run out. We assume it's just a set voltage and they're going to run out. Secondary batteries are batteries that will run out fairly quickly might be hours, and then you recharge them. So those are basically rechargeable and non-rechargeable batteries. And we have various chemicals inside of them that drive that. You can have old water cell ones. Old car batteries would actually have water that you open them up every once in a while and add distilled water inside. New ones you don't have to do that on. So probably you guys haven't experienced it, but it's not that far back. In the 2000s, like not way back. So what I'll tell you, I have about a page and a half on batteries. I think the rest of that you probably can just kind of read and just go through and fill it out. And it's just to make sure you have some basic understanding of the physical background properties of different batteries and what's going on. The other part of this week that you're going to do the homework is going to be on conductors. And specifically, I did have one other thing on batteries before I move on. So 2 things I want you to think about as you read through it. Number 1, if you remember the very first couple labs last semester, you hooked up a battery, when you hooked up actually 4 of them to get 6 volts to light bulbs. And then when you hooked them all up in parallel, you noticed that instead of getting 6 volts, all of a sudden you're getting like 5.5 volts out of them. You recall doing that?
Yeah.
Why? So if I have this, and let's just assume we were actually getting 6 volts. In fact, when I hooked up to a single bulb, there's a decent chance I'm measuring like 5.8 volts or something like that. Then I hook up, if I hook them up 3 in series, it doesn't drop anymore. The lights get dimmer, but I'm drawing a lot less current. But then we hooked up 3. All of a sudden, this dropped quite a bit, probably 5.4, 5.5, something like that. My ideal battery that we work with in class all the time, they don't change voltages. My DC power supplies I plug in the wall aren't either for anything we're going to do. There will be a point where they will. Why?
Is it because of like internal resistance in the batteries?
Well, kind of. What it really is, we've talked about loading before. We've frequently talked about like putting resistors in parallel. We talked about it with our voltage dividers, loading. So what happens is I can go in and do all my Ohm's law calculations and go, that was 6 volts. This has this resistance, this resistance, this resistance, and that's the voltage. So here's the current. And you might remember, I've done this enough times, I kind of have what these currents will be memorized. But these currents are like 120 milliamps. No, they're like 140 each. 140 milliamps each when you do this experiment. That means you're asking for like 420 milliamps. So those batteries are only rated to provide so much current. And they're rated actually in milliamp hours, which doesn't set the total amount of current they can provide at one time, but the total amount of energy they have inside before they drain. But yeah, they can only provide so much current. So what happens? You're loading this down. You're asking that battery to give you 6 volts, but the fact is the battery's chemical reaction inside just can't move that much charge from one end to the other. So as it tries to provide maximum current, its voltage actually drops. Ohm's law has to hold on all these. So it's providing as much current as it possibly can, and it's just not able to keep up. If you leave it there a long time, it'll permanently drop the voltage, because that's what batteries do. But for a short time, if you do it and then disconnect it, you'll actually notice those batteries get a little warm when you're doing this. They shouldn't get super hot, but they'll get a little warm. You'll watch they'll bounce back up to more like their normal 6 volts if you measure them a while later when they have time to recover. So yeah, our batteries can be loaded. I mean, if I put 4 of those, I got 6 volts. If I put 8 of them, I got 12 volts is what we need to start a car. But if I hook that 12 volts up to my car starter, what's going to happen if I turn the ignition?
It's going to drop way down because the starter motor is going to be asking for hundreds of amps.
Yeah, it's not going to do anything. or maybe my batteries are all just going to break open or something. But my guess is it probably won't even do anything.
Something will start smoking.
Yeah, it would just be the batteries. The car itself is going to, yeah, whatever. It's like a person trying to push him out.
I saw a guy on YouTube jumpstart a car with double A's somehow.
I'm sure you put enough together. I mean, that's how electric cars work now. They don't use like a big battery. They use a huge battery network built into them. And I don't know how big each one is individually. So yeah, so my batteries, and this is part of what we're looking at now, they have physical limitations. They're physical devices. They are not mathematical abstracts. Just like, I don't know if you recall that I said, hey, what happens if I take this 6 volt and I short it? And the answer, you would come up with Ohm's law. So I'm going to take 6 volts and I'm going to divide by, this is a segue by the way, you're going to divide by this resistance, and that resistance is 0 ohms because that's a short, right? And so you're going to get infinite current. Well, guess what's actually going to happen? If you put an ammeter in there and you didn't blow its fuse, you'd measure some actual current that's not infinity. Maybe you measured 8 amps or something like that. Why? Well, there is some resistance in this. It's a conductor, but it has some internal resistance. But more likely, hey, this thing can only provide so much current. Like, it can't actually provide an infinite amount of current. So it's going to provide what it can, and then it's going to stop, and this is going to drop. So you're going to actually measure this, and it's going to be like 2 volts or something like that. Try to provide all that current. It gets hot, 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 and shorts. Now, that also goes back to, I mentioned, if we use our power supplies, our bench power supplies, I hook these up, this one or this one, at 6 volts, and try to provide these light bulbs. They'll both work, because they can provide these, I believe this can provide 1 amp total, and that can provide even more amps. But if I hooked up, 20 of these in parallel, even those aren't going to provide the current. So they're going to be pulled down. It's going to be really bad for them. They're going to be loaded and not be able to provide that current. So that can happen there too. I mean, so that's not chemical reaction. That's just the electrical. That's control. How much current can we draw? They're both fused, so what actually happens, you'll pop the fuse and it will be done. Okay. Yes. Now I mentioned this will have some resistance. And that was my segue. Yay. Segue into conductors. So I'll start a new video now just so we can have these two separate. We talked very briefly about this